really well and had a fantastic half term and have returned revitalized, rejuvenated, and ready to go. So let's have a look at what we're doing in maths. So our WALT for today is comparing decimals. And before we get into that, you can see the 5 questions along the left-hand side that I'd like you to do for your do now. And if you feel like challenging yourself, over on the right-hand side, we have the challenge questions as well. So if you pause the video now, complete those questions and resume when you are ready. Off you go. So hopefully that's given you a chance to do the do now. So I will skip across. If you grab a different color pen or pencil and mark the questions that you have done and resume the video when you're ready. So let's move on. So as I said, our WALT for today is to compare decimals, and let's have a look at some of the star words that I'm going to be using and that I'd like you guys to use as well. So when I say one out loud, if you can say it back to me. So fractions, tenths, decimal points, equivalent, and decimals. Very good. So some of those words you'll be familiar with, others might not be so familiar, and we'll cover those a little later on. So for our review, before half term, just before your time unit, you were looking at fractions. What I would like you to do, please, is look at these shapes, and can you tell me what fraction of each shape has been shaded? So I'll do the first one with you guys. So if we look at A, to work out this bottom number, which is called the denominator, we need to count how many sections there are overall. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's then going to become our denominator. Then, to work out what the numerator is, we just have to write down how many parts have been shaded or colored in red. So let's count those. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the answer would be 9/10 of this shape has been shaded. So can you go through, please? Again, write the letters A to E and just tell me what fraction of each shape has been shaded. Off you go. So let's have a look at those answers then. So B, once again, there are 10 sections overall and 8 have been shaded, so 8/10. For C, 6 have been shaded out of 10, so 6/10. For D, 4 out of 10 have been shaded, so 4/10. You're starting to see a pattern now. And E, 2 out of 10 have been shaded, which is 2/10. Now, why are the denominators all 10 in this regard? Well, that's going to become going to become apparent in a moment's time. So we're going to be looking at decimals today. And decimals and fractions have a lot in common. So decimals and fractions are both ways of writing numbers that are not whole numbers. So we can kind of casually call these in-between numbers. So if we have a look at this red line in the middle of the page here, if I were trying to measure it, I couldn't say that it's 6 centimeters long because it's greater than 6 centimeters. But I couldn't say that the red line is 7 centimeters long either because it's less than 7 centimeters. So therefore, we can use either fractions or decimals to help us out with this. So fractions you're maybe a bit more familiar with. So how many holes are there here? What's the furthest we can go on this ruler using the centimeters? So it would be 6, wouldn't it? So the hole is going to be 6. You can't say that it's 7 because then we would have gone too far. Then, how many parts are there? Which are these little lines here? So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10 to get to 7. So just like those shaded shapes, we can say that the denominator is going to be 10. Now, in order to find out what the numerator is, instead of how many parts have been shaded, we need to see how far does this line go along this part of the ruler. So if we say that is where it finishes. So 1/10, 2/10, 3/10, 4/10, 5/10, because it's halfway. So we could say that this line is 6 5/10 centimeters. We would probably more commonly say, if we were to simplify it, 6.5 centimeters, but they both mean the same thing. We can also use decimals to work this out as well. So once again, what would the whole be? 1, 2, 3, 4, 5, 6. We can't go to 7 because the line doesn't go that far. So 6 is the nearest whole. So it's going to, again, be 6. Then when we use a decimal, we put what is called a decimal point between the whole and the part. So a decimal point is what this sort of full stop is called. And once again, rather than counting in tenths, we count in 0.1. So 6.1, 6.2, 6.3, 6.4, 6.5 centimeters. So we could quite accurately say that this red line is 6 5/10 centimeters, or 6.5 centimeters, or 6.5 centimeters. And those of you there are a couple of you that may have spotted 5/10 and 0.5 are the same as one another. So therefore we can tell that 1/10 is the same as 0.1, but we'll look at that a little later on. So 1/10 and, sorry, got an email there. 1/10 and 0.1 are equivalent to one another. So there's a quick video that I want to show you, so I'm just going to pop that up on the screen, explaining what are decimals.
When we use decimals, you can think of one whole divided into 10 parts. They're tenths. Or if you divide into 100 parts, these are hundredths. So how do we write them? Say hello to the decimal point. We place digits to the left or right of the decimal point, depending on their value. On the left are our tens and ones, and on the right are our tenths. Here she is. Isn't she sweet? When the tenths get up to 9, we need the ones. Now, what about the hundredths? Isn't he cute? So, now we've got the tens and ones on one side of the decimal point, and the little tenths and hundredths on the other. One big happy family.
There we go. So that video with the dinosaurs just explaining what decimals are. They went into, as we know, we've got the tens and we've got the ones. And then after the decimal point, we've got what's called the tenths and the hundredths. We're not going to be going into hundredths today, but it's still useful for you to know. So when do we use decimals? Well, you will have seen them in quite a lot of different areas of life. So, for example, with money is a really common one. So something in a shop may not cost £6 or £7. It'll be something in the middle. So you might say £6, 81, for instance. It might cost £6.81. And you can see you've got this here, which is called the decimal point. You've got the ones up here, and then these are the tenths and the hundredths as well. Then, if you're weighing something as well, you might be weighing something in grams or kilograms, maybe some flour, which comes to 2.1 kilograms. So it means it's bigger than 2, smaller than 3 kilograms, so it might weigh 2.1 kilograms. Or, as you can see here, on a stopwatch, if you're running a race, you might finish between 1 minute and 2 minutes. So it might be that you ran the race in 1.35 minutes. So there are loads of areas that we see decimals. So converting fractions to decimals. As I said, fractions and decimals are very much the same thing, but they're just written differently. With fractions, we've got a vinculum, so the line in the middle. With decimals, we have the decimal point, which is down here. So if we have one whole, just as you'd normally write it, you just write the number 1, with then a decimal point at the end, and you can put a 0 as a placeholder. A tenth, however, would be written like this as a fraction, but would be written as 0, because there are no holes, 0.1. And then if we have 6 tenths, 1, 2, 3, 4, 5, 6 tenths, we would write that as 0, because again there are no holes, 0.6. So 1/10 is equivalent to 0.1. That's really, really important to remember, that 1/10 is equivalent to 0.1. So I'm just going to pop on my visualizer now, and we're going to do some questions together. Right. So remember, I've got a number here represented by a pictorial representation by my Deans. Now, in order to work out, we have no hundredths here, by the way. Those would be represented by the small little blocks. But we're not going to focus on those today, but it's still useful for you to know that they're there. We're going to count the number of tenths first, just because it's good, in case there were over 10 and you had to regroup, it's better to count the tenths first, the smaller number, before the larger one. So how many tenths are there? There's 1, 2, 3 tenths. So that's going to go behind the decimal point. Then, how many ones are there, or how many holes are there? There's just 1, so that goes in front of the decimal point. So we could say that this number is 1.3, and there are no hundredths. So 1.3 we could write this as. So I'm just going to move this to one side and grab another one over here. Oops, sorry. There we go. Now, let's do this one together. Which are we going to start with? Are we going to start by counting the ones or the tenths? Well, we're going to start with the tenths because, as I said, just in case there's over 10 of them and we need to regroup, it's best to do those first rather than the other way around. Always best to start with the smallest one. So, let's count how many there are. 1, 2, 3, 4, 5. So which section that's going to go in? That's going to go in the tenths. And then how many ones are there? 1, 2, 3. So we could write this as 3.5. Or if we were doing it as a fraction, can you think how we might write that? 3.5 as a fraction. Well, I remember that 1/10 is equivalent to 0.1. So if there's 0.5, it's going to be 3 5/10. So fractions and decimals are the same, they're just written differently. Now, I've got another whiteboard that I'm going to put in front of you. What I'd like you to do is pause the video. Can you work out what the number would be here? How many ones, how many tenths? So can you please pause the video now and just write down on maybe a bit of paper or just think in your head, what is this picture, what are these Deans going to be represented as numbers? Pause the video now. So hopefully you've had a chance to look at that. The first thing we're going to do is count the number of tenths because there aren't any hundreds, so we'll start with the next smallest thing, which is the tenths. How many are there? 1, 2, 3, 4, 5. Now, how many ones are there? Okay, there aren't any as far as I can see. So, we can leave that blank and put just 0.5, However, before a decimal, we should really leave a placeholder. So we're going to pop a 0 in there. So we can write it as 0.5, but it's best to leave the placeholder as 0.5. Or if we were doing that as a fraction, can you tell me what that would be as a fraction? It would be just 5/10, because there aren't any holes, so 5/10. Okay, now for the final one, this time I have the number written, which is 2.6. So let's do the Deans together. So we're going to again start with the smallest number. And how many tenths am I going to need? I'm going to need 1, 2, 3, 4, 5, 6. Great, so that's the tenths done. 1, 2, 3, 4, 5, 6. And how many ones? I'm going to need 2, 1, 2. So this then represents 2.6, or 2 6/10. Okay, so what I would like you to do, please, for your first task is you're going to have some pictorial representations over here that I would like you to convert into decimals. And then once you've done those, you've got some decimals that I would then like you to draw the pictorial representation with Deans over on this section here. So if you've got the sheet, then that will be nice and easy. You've got that all written there. If you don't, however, it's no problem at all. So I'm going to just turn back to my visualizer and show you how you can do this without the sheet printed. So I've just got the sheet here to tell us number 1. So number 1, we've got these here. The first thing I'm going to do is draw that pictorial representation. So again, all work should be done with a ruler just to make it really nice and neat. So I'm going to draw the pictorial representation. There's 1, 2, 3 of the long Deans. So you can do that as you wish, horizontally, vertically. I'm just going to choose vertically. 1, 2, 3. Then we need to write what's the decimal here. Right, so how many, I'm going to do my decimal point. Always remember to do that. So I'll pop that in the middle there. So how many tenths are there? 1, 2, 3. So that's going to go after the decimal point. And how many how many ones are there? Well, there aren't any ones there. So I can leave it as 0.3, but what do I need? What should I really put before the decimal point if there are no ones? A 0. So that would then be equivalent to 0.3. So I'll leave the questions up on here. If you can pause the video now, and then we'll look through the answers in a moment. Off you go. So hopefully that's given you a chance to look through. Grab your different pen and pencil and let's go through these together. So for the first one over here, this one we've already done. It's 0.3. For this one, we have 0 ones. So we put the 0 there, and 1/10. So it's going to be 0.1. Over here, we have 1, 2, 3, 4 tenths. So that's going to go over there. How many ones do we have? Well, we've got 1. So the answer is going to be 1.4. So make sure you're marking these as you go along. Then here, we have to change the decimals to our Deans, to our pictorial representation. So how many ones are there? Sorry, this is not, it takes quite a bit of practice to get these right, so I apologize if they're not that neat. So there's 1, and how many tenths are there? 6. So 1, 2, 3, 4, 5, 6. So I'm sure yours will look like a neater version of that. For the next one, we've got how many ones? We've got 4. 1, 2, this is a better idea. 3, 4. And how many tenths do we have? We've got 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Great. And then for the final one, how many ones do we have? We've got 7. So 1, 2, 3, 4, 5, 6, 7. And how many tenths? We've got 1. Oh, doesn't matter that they're going sideways. 2 and 3, like that. So this is what your answer sheet should roughly look like, although a bit of a neater version. So moving on to the next section now. This is where we're going to be comparing decimals. So up here, I have the pictorial representation with my Deans, and that has 4 tenths and 0 ones. So that's going to be written as 0.4. And this number over here has 1 1 and 1, 2, 3, 4, 5, 6 tenths. So it's going to be written as 1.6. What we then need to do is write the correct greater than, less than, or equal sign in this box. So I've got my steps to success up here. So I'm going to do the first one. Just watch me do this. So the first thing I'm going to do is label the place value. So this is going to be our ones, and this is going to be our tenths. And again, our ones and our tenths. And remember not to get the tenths confused with tens, because of course tens would be over here, for example, if it was 11.6. So these are our tenths. So I've labeled the place value. Next, compare the ones. Which is greater? Well, this has 0 ones. That has 1 1. So therefore, I can tell that our sign is going to be 0.4 is less than 1.6. We didn't need to go on to step 3 and 4 because the ones were different. Let's try this one. So we've got 2.7, 2.1. So what's the first thing that I have to do? So I need to compare the ones. So 2 and 2. Hopefully some of you calling out at the screen, what's something that I've forgotten? Oh, yes, Mr. Parker, you haven't looked at your steps to success. I need to label the place value. So again, our ones and our tenths, our ones and our tenths. Now I can have a look at step 2. Compare the ones. Which is greater? So we've got 2 and 2. Oh dear, so I don't have a direct answer here. So let's go on to step 3. If the ones are the same, look at the tenths, which is the one after the decimal point. Which is greater? 7, so 0.7 or 0.1. Well, that's clearly greater. 0.7 is clearly greater, so it'll be 2.7 is greater than 2.1. So pause the video now. I'd like you to do this one by yourself, follow the steps to success, and then we'll go through it together. Off you go. So hopefully that's given you a chance to do it. I'm just completing the first step to save a bit of time, so I've labeled my place value. Next thing we're going to do, compare the ones. Which is greater, 3 or 9? 9 is definitely greater, so 3.5 is less than 9.7. So, one more to do here. Again, just if you can pause the video and complete this one. Right, so while I again complete step number 1, which is labeling the place value, and I can't stress enough how important that is. So, compare the ones, 8 and 8. Right, they're the same, so we need to move on to step 3. If the ones are the same, look at the tenths. 8, 9. Remember, the crocodile always goes for the bigger number. So 8.8 is less than 8.9. So, task 2. What I'd like you to do is have a look at these numbers over here. And you just need to, like we've just done, insert the correct greater than, less than, or equal sign into these boxes. So again, we'll do number 1 together. So 1.4, 2.0, and then you just need to either, we just write the correct symbol in these boxes. And then for the second section, what you need to do is write these numbers, these 5 numbers, in the correct order, starting with the smallest. So the smallest one goes on this box. So if, for example, you think 4.2 is the smallest, you'd put 4.2. And then if you thought it was 6.1, put 6.1, and then go all the way to the end. So you get the idea. So if you can complete that section, that would be absolutely fantastic, and come back to the video once you've finished that. Off you go. So hopefully you've finished task 2. Let's have a look at those answers. So if you can again insert the correct, mark your work as you go along. And I understand because of my recording symbol being in the way, I'm just going to move that up a little bit so you can see these bottom ones. So pause the video now and just mark those ones for me, please. Great. Now let's move on to the final section, which is our reasoning. So we have 2 opinions here, one from Annie, one from Dexter. So can you tell me who is correct? And really importantly, explain why. And then for the second bit, explain what's the same, what's different from 6/10 and 6/10. And then write a number that is more than 5 but less than 6 in decimals, please. Okay, off you go. So hopefully, guys, you have finished that reasoning. Let's have a look at the answers. So for this one, both children are correct because 1 whole is equal to 10/10. So 1.2 is equal to 12/10. So they're both absolutely right in that regard. And sorry, I've missed this one over here. 6/10 and 6/10. What is the same and what's different? Well, they both include the number 6. There's both 6 as a quantity. What's the same? Well, 6/10. What number would 6/10 be? So 6/10 would be 60. And 6/10, what would that be? That would be 0.6. So that's the difference between them. And then finally, write a number that is more than 5 but less than 6. You could do anything from 5.1 up to 5.9. So 5.2, 5.3, 5.4, etc., etc. And that, ladies and gentlemen, is everything. So thank you so much for tuning into today's maths lesson. That is the start of our work on decimals, which we're going to be continuing throughout this week. Hope you enjoyed, and I'm looking forward to seeing all of your work on Seesaw. Really glad to have you back. Okay, bye-bye.